So hey everyone, I'm Yash and today I'm going to show you something very special. This is the Google's Gmail loader that animates. It is also seen in many places in the Pixel device. So I've just called it the Google Pixel Loader V1, or we can just call it the like Gmail Pixel Loader, something like that. So let's just take a look like how does it look like and how does it feel when you are on an actual phone. So here I have a like a snapshot, and like this is the kind of way that I want to start it. So the way we can see it, that whenever we open a new mail and the mail is still loading, then we see something like this. It has a minimum value that is like predefined, like a 5% or 10%. That is like the circle is filled with a bit of a loader, and it spins and it takes up more and more space, and you can just see like now it is like on 25%. I've seen that it can go up to like 90%, somewhere like that, and after that just the mail comes up. Usually like for my GIF that I saw, that I was only able to fill it up till here like 30%, and then I saw the mail itself. So yeah, this is the loading state of an email, and I really love that how it has this squiggly kind of lines, and I wanted to make it. So yeah, that was the whole idea. So let's start off like we have a basic version here, and I'm going to just explain like how this is made and how we have created this. So we have like an SVG that has this squiggly line. We can just remove all the CSS at the moment to just see like how does the SVG look. So yeah, we have like a heading so that we can have visually hidden semantic meaning to it. We have like a progress bar so that we can actually show the actual progress value, which is also visually hidden because this is basically a progress for our use case. And we have this whole SVG. The way we are changing the value is that we have a p value to this, and this particular p is the progress, which is taking the value from progress. Because we do not have a real kind of a loading state or a real p value coming from an API call, something like that, then that's why, or a real loading state. So that's why we are just defining it to like 0, and then inside a set interval we are just saying, yeah, just keep switching between 100 and 0 over 3500 milliseconds or 3.5 seconds, because each of the animation is just going to take 3 seconds. And I'm going to show you like how does this work, like what's the basic concept, like how am I animating this, and we will just take it up one notch further than this. So the very first thing is we have something called a stroke dash array and a stroke dash offset. What it does is that it says that we want something that has an offset of 1000, which could be let's just say a distance of 1000 between each of the lines, and then we just change it to 0, which is like to draw an SVG. Usually the dash or array and the dash offset are within the SVG view box. So the way that we see it, that this is the view box, and this view box is like 340, 333. But 1000 offset would be like the offset is now starting outside of the view box, so we are not able to see anything. So this is basically, these two lines are basically, let's hide my SVG, just make it so big, this make each of the dash array offset, each of the lines that make up my SVG so big and so far apart that they are just outside like 1000 distance, and each of the lines are so big like 1000. And then I'm just saying that just come back to 0 and make sure that we can actually whenever we do that, we just kind of, this technique just works in a way that it kind of just draws into the whole thing that is coming back into the animation. So yeah, it animates back, and this works for any kind of SVG, and that's the best thing about this kind of shenanigan or trick. That yeah, you can also like take a look about it, just read about it, make sure that you understand like how the array offset or the distance between the individual lines that make it, or the chunks that make it, and the distances, that how it is like coming back into its own space, and making sure that you have these each of the particular dots that make the whole path just animate it into the SVG. So yeah, without going much deeper into it, I believe that we covered it. We would be seeing that how we have made it. So we have this SVG. I will just show you later that how did I created this. And then we have like a background body that is just covering up the space, making sure the SVG is on the center. I can just hide this. We have a progress that says I'm at 0%, but yeah, we will change it using JavaScript. We will just make sure that we can just change it to 100%. And then we have a few things to take care about, that the path has a stroke color of this CAD, which is like this blue color, we could have just totally removed it because we are already supplying it from here HTML itself. It has a stroke width, which is like the width. It could also have been eliminated. This is also something that we are supplying from the this HTML itself. But yeah, I wanted to just make sure that we do not forget about it. Make sure that people, whenever we create SVG and we export it, usually we do not take care or give like any care about these kind of values that we have here, and we just focus on the defaults. But yeah, this is where we want to like make sure that we are actually having the right values, the right width, whatever we want. So yeah, just showing it in CSS is just easier for us to see. Yeah, let's just keep going. And then we have this dash array that says that I have the length, which is a very high length, which is equal to the total length of the path, so that my lines are just totally outside and we cannot see it. And this length value, I'm getting it by saying get total length, which is like a set default API call that we can make to path, and it just is covered by the HTML path element itself. So we can just say that, yeah, I want its total length, but later I want to change its total length to make sure that it just transitions back and comes back into the whole SVG, and just we can just draw the SVG out from there. So that's like what's happening here. So yeah, we have set it to this, and it allows us to like just say that, yeah, it was in something that we can just draw out. The next thing is that we have this dash array offset. Now what's happening here is that we are multiplying this to 1 minus progress, which is like saying, hey, if my progress is at 0%, then I do not want to draw any of this, and if my progress is like at 100%, then I want the complete path that is there. So let's take a look like how does that happen. So yeah, let's just see that. I will just try run through this. Let's just say that we have the set property p value, which is giving us a value of 100, or which is like divided by 100, it is like saying 1. So this 1 minus 1 would become 0 here, and we would have like a multiplication with 0. So the dash array offset would be 0, which is like it will just come back. So seeing from our CSS trick earlier example, we were just setting up the animation back to 0, making sure that we can just draw it back. This also works in other wonderful ways. So just to show you, like this is not just for 0 or 100. We can actually make like let's just say 50 or 100. Make sure that we can also animate in any of the in between values, and this would work out. So that's like a small mathematics algorithm that I have just put it here. You can just simply copy it, make sure that you can just directly use it, and it will work out of the box. So yeah, this is basically algorithm to change the progress value into the actual stroke dash offset value, so that we can make sure that we can make the path, draw the path out. And yeah, so I think one thing I want to cover here before we move on is how do we draw these? Like how do we have, like I haven't shown you an example with the background circle. I have just shown you an example of how to draw out and make sure that you have an algorithm in mind, do not have to worry about it at all. And how do we just have an SVG out that is animated. So thinking about it, like how would I draw this? Let's take a look. And the first thing that comes to my mind is I want to have a star here and want to have multiple sides to it. Let's just say 8 sides, and I want it to have this kind of a radius. So, and yeah, we can just make sure that the height and width are the same, like 240 would be nice. And then the last thing is that I want to remove the fill and just have a stroke, and the stroke can have a width of 10. And yeah, that's it. So we have a very nice wonderful this star kind of a pattern that we are using, a squiggly line circular pattern we can just call it. And the next part is like we want to align this to the circle. Like you can see that now the circle has a squiggly line which is outside, which is inside, so both of them would not have the same size. This is why we are using a frame, and we are just putting both of them into a frame of equal size. So you can see that this is 250 by 250, and this frame is also 250 by 250, and which is like what we need to make sure that they are on top of each other and not like having some kind of an offset between each other. So that's what we have used. And finally, just put them one on over each other. You can see that the squiggly line is above or below, and then this is how we are done with the whole drawing thing. So yeah, let's keep moving. So till now what we have covered is, we know that how we have something like a stroke here, like a stroke which is like in terms of stroke color, the stroke width, also the stroke line cap, I believe, which I didn't cover, which is like to make sure that this appears like a circular pattern whenever it is covering. So if I remove my stroke line cap, it would look like not a circular pattern. It would look like more like a straight line. I will just change it to but, which is like to, yeah, this one. So this doesn't look really nice because now the whole roundedness effect is removed. Yeah, it's called but. I would prefer to call it like rectangular shape, but yeah, both do fine. So let's keep moving. So we have now another thing to look at and another thing to care about, which is like, how would it work if we have this kind of a scenario? You can see it is working really nicely, but how does this whole thing work? So the first thing, and let's just remove and forget about all the CSS, all the JS, that doesn't exist for us for now, and just care about the semantics first. So we have a section, we have this as a container, we have some visually hidden progress loader text that just says that I'm a progress loader, and then we have this visually hidden progress bar, which is like, this is actually a progress bar and taking values from a progress bar. And then we have this SVG. This SVG is really nice. What does it do? This SVG has my first path, which is like my circle or this background path. I'm calling it circle. And it also has my second path, which is the loader, which is like this squiggly line blue color loader that we have. And both of them, and I think one thing I did differently in the previous example was, I was getting the total length of the path by using the HTML path elements web API, but we can just say path length, and this normalizes it. What I mean by normalization is, now we do not have to take the whole path and make sure that a dash array offset goes from the whole path to 0, so that we can have that proper dot animation that is actually making this whole thing and the whole shenanigan. We can just not get the actual value of the whole path length, but make sure that it is normalized between 0 and 1, and that's like what normalization is. So 0.5 of this and 0.5 of this would be like 50% of the total path length of whatever path this is covering, and 50% of the total path length whatever path this is covering. And this like eases our job onto the JavaScript side. We do not have to write any JavaScript to get the path length and all. So yeah, now we have a basic understanding. We have a stroke, we have a stroke width, we have a stroke line cap round, and we have a path length. And we understand that just animating between the dash array offset to like having a high value to making sure that it just comes under the like 0, that would allow us to animate it. So once we have this much like shenanigans stuff covered, then let's look at something that would make sense in terms of CSS. So the very first thing is that we are starting our progress with 10%. You may have seen it. I will just reload it to show you. Is like we are starting at 10% of the loader. So yeah, that's nice. And this EPS, don't worry about it. It doesn't hurt you for the moment. So you do not have to care about it. So that stroke dash array is like 1, which I told you, like, yeah, we want to make sure that this is like 100% or whatever this value is. And now we are caring that the dash offset, like the dash offset is something that we are making sure that 1 is covering the loader, that the loader is covering 1 minus progress, and this is covering the progress. So what does that mean? And let's not worry about the EPS part for the moment. This EPS is just to mention, like, we have some kind of an overlap which this EPS or this epsilon or this gap kind of thing, make sure that does not happen. So you can see that there is some kind of a bit of an offset or this kind of overlap that it covers up. But yeah, what does it do? So this one says that, yeah, I am going to cover the progress, the actual progress values. So I am going to care about that. And this says that, okay, you care about that. I am the circle. I am going to cover the rest of the place that exists. So This is like I'm covering X%, and this is saying I'm covering 100 minus X%, so that the whole circle is covered. Uh, and the way that dash offset works is that if the value is 0, then it is 100% fill. So like that's a inverted logic, and over the top of inverted logic we have another top of inverted logic by saying 1 minus this. So 1 minus 100%, like just say the progress was 100%, you are 100%, you have the progress set to 100%, then this would mean that this is 0, and 0 in this dash offset would mean that the full path of the loader is there. So the loader exists for the full path, and we do not have any amount of circle. And yeah, this is why we do this 1 minus. The other path where we are having this plus EPS is just because we want to make sure that this starts a bit from here and doesn't take up the overlapping space, that both do not start from the same place. And this is what the dot EPS, this is just like an offset for this. And then we are rotating and scaling it. This is more of a thing because if we do not rotate or scale it, both of them will move from the same starting point in the same way, or would not move in the like the way that we wanted. Like this one is moving on this side, this one is moving on this side. So this is like more of offset things that we want to cover with our maths. And this is like 180 minus this what this EPS has given us, this 20 degree extra. So let's just try to see like and I think that this EPS thing is something which is like an offset, so doesn't really make sense to understand with that. Let's see what the real thing looks like with this values, like not have any kind of rotation, not have any kind of scale, and what does that look like. So yeah, this is the default, like how things look like, and this is from the starting point for us. In this you can just see that they are complementary but kind of not making sense. Like they are filling each other's space, but we needed some kind of an offset, some kind of a rotation, some kind of scaling, so that they could actually complement each other. And that's why those whole EPS and rotate, and even in rotate and in scale we have some other things that came up, so that we made sure that yeah, now you can see that why we needed that epsilon or the gap. You can see now with rotate, with scale, we still have this squiggly line, everything that we wanted. This needed some kind of an offset because this needed some kind of an offset. If I just the best way to understand it is like to see it in like real time. So let's see. So if I do this calc and I say that yeah, subtract it from my variable of minus EPS or epsilon, then it would make sure that it starts from a point. So let's see, yeah, and let's see if I have, okay, what did I do here? Should be plus. So yeah, let's see what happens here. And here it goes. Okay, kind of not animating. I will just go a bit back so that we can just see the effect here. Let's see. All right. Okay, I removed that from the start, so it was commented out to remove that, so it was not working. But yeah, now at this point, what if the rotation was 180? What if this value of epsilon was 0? And we can just do it like this. So we have like no offset and the default way of seeing things. And you can just see that there was a bit of a overlap. We never wanted it. Now what happens if this value was 0.06, which is like eliminate this kind of a overlap, but it didn't really eliminate that overlap. It says that yeah, I will just, you care about the overlap yourself by rotating, but I have cared about like giving you enough space that you wanted. And then came this 20-degree effect so that we can have this whole thing at the right place. And yeah, that's it. So what we understood from here is that we always want to draw our SVGs whenever it is a challenge where we are making sure that yeah, this SVG is drawing up, another SVG is drawing up. We want to make sure that we use the same variable. For our case it was minus p or progress, and both were using the same value from JavaScript. Both of them were getting this value of progress, and the progress dot value was changing, and they were having this set property that was getting the p value, which was like progress value divided by 100, so that this could actually use those values. and then both of them were drawing themselves by this dash offset shenanigan. We will call it a shenanigan or trick more than something that makes a direct sense, and they were using it. That's why I was giving so much stress to it. And finally we have some kind of a gap or EPS epsilon, that is like more like a mathematical term to just punch in to make sure that that particular offset stuff is taken care about. And just this is the last thing, that in the GIF that we saw there was a particular rotation, right? So let's just have the rotation turned on as well, and the kind of effect that it shows is not exactly like how Gmail does it, because the Gmail progress is not animating kind of this way. It is just moving totally in one manner, like totally increasing and never decreasing. But yeah, this looks quite really nice. Like this looks like I'm sure that this looks more like a musical kind of a thing where something is, and I believe that the music player also uses a similar kind of a squiggly line, which I really love. So yeah, that is all about this. We just use one kind of a technique in CSS. Everything else was just maths, and I really hope that you enjoyed it, and I hope that you can just take a look at the code. I will just send the code in the video description, and maybe you can just make your own version of it, just remix it in Codepen and just enjoy it. So yeah, that was all. Have a very great day ahead. See ya. Until next time.